Good morning, everyone. Let's get started. So let's quickly rewind what we have learned yesterday. So yesterday we looked at how to do the implementation of a stack using a queue, correct? So can someone tell me how can I do queue stack implementation using queue?
So you need to create a queue data structure inside a stack.
Okay.
And pop and add.
Yeah. First you need to add the element. Okay.
Yeah.
Add the element to the queue, and then from 0th element until the size of the queue, you have to pull the element and add the element, so that you are rearranging the elements which follows the last in first out order. And then whenever you do the poll method, it gives you the last in first out behavior, correct? Yeah. Now apart from that, we also looked at how to sort the hash map by keys, how to sort the hash map by values, correct?
Yeah.
So what should I do if I want to sort the hash map by keys? What should I do?
You need to convert to key set, and with the key set, you need to override the comparator interface. And if it is key, we have to use that return of the get key ID, and if it is values, we have to return with the values.
Yeah. So basically, the idea is here to implement, see, in order to sort, we have the sorting algorithms, right? In insertion sort, bubble sort, selection sort. But at this point of time, we do not know what the sort algorithm, right? The best way to use is collection.sort method, which will do the sort. But the problem in the collection.sort method is the collection.sort method takes a list object. So your responsibility is to convert the map object into a list object. So in order to do that, first, you will call the entry set method. What does the entry set method will do, guys? What is the return type of entry set method?
It is going to return an entry of the generics, whatever we passed in the first as a set of the things.
Yeah. So that means entry set method will return a set object. Inside a set object, the generics will be an entry object. Inside an entry, it will store the key and value. Am I right?
Yep.
Yeah. So now once you get a set, how can you convert the set into a list?
You should use linked list. Yeah.
Yeah. I mean, there is one constructor, you link list class constructor, you can pass that object so that you will get it. Now after that, if I am trying to use collection.sort, will it work? I will use only collection.sort method. I will not pass the comparator. If I use like this collection.sort, why is it showing the compilation error? Line number 41.
Because it goes to the L and see there is no comparators, right? I mean, the L is the list.
So that means generally collection.sort method takes a list. So internally inside the list, what is the generics? That generic should implement a comparable or comparator. That is what it is expecting. But here inside my list, what is the generics? Entry object. Does the entry object implements a comparator comparable? No, it's a predefined class. It is not. So that's the reason we cannot use the collection.sort method. We have to use a overloaded method of collection.sort, which takes a comparator, right? So I am passing a L and I'm passing a comparator. Now, whenever you are writing a comparator, can I say whatever the list is taking the generic, the same generic should be used in the comparator as well? Yes or no? Yes.
Yes.
And whenever you are passing a comparator here, you are overriding the compare method. Now here, if you want to do the sorting by key, o1 dot get key, this object name followed by get key. If you want to sort by value, can I say you have to get the get value? So by writing like this, you can do the sorting, either it's a key or value. Now, once that is done, if you print, you will get it. But the thing is, the interviewer might ask you, I have given you the map. You also return me the map. Then what you have to do? You have to iterate over this list and then create a linked hash map and then pass the data to the linked hash map. Why only linked hash map? Because linked hash map follows the insertion order, right? So this is what we have learned in the yesterday class. So any questions?
No, we clear.
So guys, there is one more thing, queue implementation using stack, that I'll talk about that in the next class. So today I do not have the multi-threading class because I have a meeting at 8:35. So I will be taking this class till 8:30, like another 15 minutes extra. So I want to cover the trees topic, and queue implementation using stack, I'll cover it in an upcoming class. Okay. So now let us go into the new topic called trees. So do we have a predefined linked list class in Java? Do we have a linked list class in Java?
Yes.
Yes.
So
Yes.
similarly, do we have a class stack and then some classes for queues?
Yes,
Yeah. But for tree, do you see any class?
Tree map.
Tree map is there. I'm talking about only tree.
No.
No. So there is no predefined class. No predefined class as tree in Java. So we have a tree set tree map. That is different. We have tree set and tree map. That is different. Okay. But if you say the tree is not there. So as the name itself, so can I say the tree is nothing but it will have a parent and it will have a child, something like this. You might have seen from so many days, right? This is the diagram. This is called as a tree, correct? Yes or no?
Yeah.
So now today in this class, so we'll try to learn the terminology and we'll create a tree data structure. So because we do not have a class called tree, so now if I want to represent this, see, this is a tree, whatever I have drawn here in the orange color is a tree. Now in this tree, let me add the node. So here some values. Now this is a parent, this is a child, this is a grandchild. So if I represent something like this, so there may be a possibility that they will be asking whatever I have drawn here, please represent this in the try to represent this in the Java programming. So then can I say if I do that, then can I say that is a tree implementation? So I have drawn here diagram. See, that means for 10 is a parent. For 10, what are the childs? 5, 6, 7, 8. If I represent this somehow in the Java, can I say that that is nothing but a tree representation?
Yes.
Yeah. So that also we are going to see. Okay. So, but in order to use, see, for example, if I want to create a linked list, I have created my custom linked list. But at the same time, Java has provided one class called linked list. I can use that and I can do. But for tree, specifically for tree, you do not have any class provided by Java. So it's we have to implement the tree. So we are going to see how to do. Okay. Now in that we are also going to see in order, pre-order, post-order. And basically that is nothing but a recursion algorithm. We are going to see that as well. Now see what is a tree now, first of all. Tree is a data structure in which, see, if I ask you what is a linked list, what is the answer? Linked list is a data structure in which each node will contain the address of next node, correct? Am I right?
Yes.
Now, so the data will be stored in a linked list in the format of node, but each node will contain the address of next node. And the last node is not pointing to anyone, hence the last node address will be null. Okay, this is my answer for linked list. Now, similarly, if I ask you what is a tree, tree is a data structure in Java, or like see this tree is a data structure. It can be implemented using C++, or .NET or Python, anything. But currently we are learning using Java, so I'm telling Java. So tree is a data structure in which one parent and multiple childs will be there, and each child can have another multiple chains. Correct? Yes or no? Here, if you look at the
Yes.
tree in the real life, if you see any tree, there will be one trunk. From the trunk, there will be different branches will come, and that branches will have again child branches. Correct? So a tree is a data structure in which there will be something called parent node, and then child nodes. Okay. Now there is one terminology called binary tree. What is a binary tree? What is a binary tree? A tree can be called as a binary tree if only it has two children. See, this is A. It has a child called B and C. At maximum, see here in this example, how many children that the 10 has?
4.
4. So that is a normal tree. Now, what is the difference between a binary tree and normal tree? So a tree can be called as a binary tree only if it has at maximum of 2 children or 1 children or no children. Okay. So these are, see, a tree, a tree can be called as a binary tree only if the parent has at maximum of 2 children or 1 children or 0 children. Okay. So look at here. In this diagram, can I call this as a tree?
No.
Why?
Not
You
a child.
don't have children.
So it may or may not have, right? See, whenever you plant a tree, will it have a tree? Like only one small plant you will take and you will put it. So that time it will not have, it may not have a branches also, right? So this itself is a tree, but it does not have a child. It may, correct? So see, this can also be a tree, but it does not have a child. See, if I create a linked list without nodes, can I create a linked list object? Yes, my head will be null, correct? See, if I create just a linked list, L equal to new linked list, at that time, do I have a nodes in the linked list?
No.
No.
No, then can I call it as a head linked list object only, correct? But the nodes is not added. Here also, the tree is there. So the tree can have only, so this is also a tree. Now in which there are no children or there is no, only parent is present, there is no children. Now in this one, so here in this one, can I say this A is a parent and B is a child, one child only, correct? And this is A is a parent and these are having 2 childs. So a tree can be called as a binary tree only if each parent should have only maximum 2 childs, or it can have 1 child, or it can have no child. Now I will draw some trees. You guys tell me whether it's a binary tree or not. Is it a binary tree?
No.
Yes.
Why? Why it is not? Someone said no. Why? See,
It only should have 1 child, 2 child, or no child, right?
yes.
But it
See,
have
if you
multiple. It's
look
considered as a
at here.
trees.
Look at here. A is a parent, correct? For A, how many childs are there?
2.
Childs.
Okay. Is it satisfying?
Oh, yeah. Yes.
Again, this is, see, assume that this is a grandparent. This is a parent. This is a child, correct? If you look at our family structure, it is similar to that, right? See, my grandparent has my father and my auntie. And my father has like myself and then my sister. And then my auntie has another son, correct? So that means at any point of time, the parent is having 2 childs or 1 child or no child, correct?
Yes.
Is it a binary tree?
Yes.
Is it a binary tree?
No.
Because it has 3, correct? So a tree can be called as a binary tree only if it has maximum of 2 children or 1 child, like it can have 0 children or 1 children or 2 children. That means maximum of 2 children are there. Now this one is called, generally it is called as a parent. Okay. And see, it at maximum 2 children can have, right? So this is left side is there. So this is called left child. Okay, this is called right child. Let me write in the above diagram as well. So this is called parent. Okay, this is called left child. This is called right child. Now in this diagram, so this is a parent. This will be another parent, but see, this will be another parent, and this will be a left child to this parent, correct? Left child to A. this will be a right child to A, but for this one, it will become a parent, correct? So that means if you look at here, your like our father, to me, my father is a parent, but my father is a kid, child for his father, right? You understand, right? What I'm trying to say. It's like a polymorphism. One person exhibiting the different characteristics. See, if you look at myself, I can play a role of father. I can play a role of brother. See, to my sister, I'm a brother. To my daughter, I'm a father. To my wife, I'm a husband. Right? I'm playing a different roles, correct? So one person exhibiting different characteristics is called as a polymorphism. Like what I meant by here is, so there is a terminology called parent, left child, right child. Okay. Now in the linked list, what is the head, guys? What is the meaning of head in linked list?
Starting point.
So it's a first node will be always a node, correct? First node. Now similarly here, if you look at this diagram, let's look at this diagram. Is it a binary tree?
Yes.
Okay, in this one, who is the top starting? Where is the starting point?
A.
A.
So this one is also a parent for all, correct? So this, the top most element is called as a root element. Okay, the terminology, see, the head in the first element in the linked list is called as a head. Now, similarly, the first element or topmost parent is called as a root in tree, and this becomes a left child. This becomes a right child. Again, this is a parent, and this becomes a left child. This becomes a right child. Hope you understand.
Yes.
Okay. Now, let's get into some other topics. Now, there is one more topic called BST. BST means binary search tree. Binary search tree. What does it mean? So, for example, if I take my root is 100, okay? My root value is 100. Anything less than 100 should go towards left side. Anything greater than 100 should go towards right side. Now, for example, 98, left side, 101 here. Now, again, like if I put a 78, where should come? 78, done. Now, if I put 89, where should I come? So you start with here. Is 89 less than 100 or greater than 100?
Less than.
So as per the concept, it should come to the left side, correct? But left side immediately, do you put here? No, but already one element is there. Is 8 same, follow the same rule. Is 89 less than 98 or greater than?
Yeah.
Less than, correct? So again, you have to come to the left side. Now again, left side, you have already a node. Is 89 greater than 78 or less than 78?
Greater than 78.
So can I say which side I should go? Left or right?
Left side.
Left side.
Left side, it is lesser. If it is a greater,
Right
side. Can I say?
Yes.
I am talking about 78 right side, correct? Agree? Now, if I want to put 60, where do I start my logic always? I'll start with a parent root node, correct? Okay. Now here, now in the root node, I will compare the 60 with 100. Is it greater or less?
Less.
So which side I should go? Left side to 100,
side.
correct? Yeah. Again, left side to 100, there is one node already. What is that? 98. Is 60 less than 98 or greater than 98?
Less than 98.
Less than 98.
So where should I go?
Left side.
Towards the left side.
Left side of 98, correct? Yes or no?
Yes,
Done.
yes.
Already I have 78 again. 78 is lesser. No. So it's again less. So I will go left side. Do I have any node left side to the 78? No. I'll put
No.
here. Done. Now, if I am trying to put 99, where should I go? First, where should I start? 99?
From parent.
From the root
So,
node.
so 99 less than 100? True.
Yes.
Now,
True.
and then to the 100 to, I should go towards left side of 100. Done. But left side of 100, what is the node already present? 98.
98.
Now I have to compare again. 99 is greater than 98.
Yes, 99 greater.
So can I say it will come here?
No.
Yes.
Yes.
So that means a tree can be called as a binary search tree in which your root node is a key here. Any element lesser than the root will be towards left side. Any element greater than the root towards right side. That means the same logic you have to continue till the logic last place. Now if I have to put 105, can I say I will come here? Now if I put 103, where should I come?
Left side after 101.
Left side of here, correct? Hope you understand. Right. So this is the binary search. Now, what is the use of binary search tree? Now, for example, assume that these are the numbers. These are the numbers that are given in the array. 10, 98, 78, 60, 89, 99, 101, 105, 103. Now, assume that this is a given array to you. Okay. If you are using the array and I want to find out where the 103, what is the position or whether in this array 103 is present or not. My question is, write a program to check whether 103 is present or not. So if you want to do, how do you do the program? If it's an array? Shall I repeat the question?
We will loop the array and we will find out each index contains.
Can
is
I say
map.
I equal to 0, I less than a dot length, I plus plus, if a of I equal to 103, correct? Now, if you write like this, how many iterations you will do in this example? 0, 1,
Based on
2,
length.
3, 4, 5, 6, 7, 8. You tell me now.
8,
Okay. So is it 8 or 9?
9.
So 9 iterations you have to do. In the 9th iteration, you will get the true value, correct? Yes. Now, assume that instead of this array, you represented these numbers in the form of binary search tree. Can I say if I represent this one, so I will take that my parent is this one. I have represented this in the form of binary search tree. Okay. Now, how many iterations I need to find out 103? I want to find out 103. Okay. Where should I start my logic? I'll compare with my root. 103 is greater than 100.
Yes.
So can I say I should go only towards left side, correct? Sorry, right side. Towards right side, correct? Do I need to search all of this? Do I need to search all these elements?
No.
Not required, correct? Done. Next, 101, see, 103 is greater than 101?
Yes.
Yes. So I need to search only these two, correct? If it might have elements like this, correct? Do I need to search all of these elements?
No need.
No.
Can I say I am reducing in each iteration, I am reducing the half of the values, correct? Only one side I am going. So now again, 105, do you search? You see, it might have elements like this. Okay. Now if I compare 105, 103 is less than 105, yes. So I will search only this part, correct? So in how many iterations I am going to get? 1, 2, 3 iterations itself. But here you are doing 9 iterations, correct? Hope you understand.
Yes. Yes.
So here the insertion may take time, but retrieval is very fast, correct?
Yeah.
So if you remember in the hash map, we had if you are following a linked list approach, there is a performance issue. And if you remember, I told that the performance issue is replaced by binary tree approach, correct? I'll come to that again.
Yes.
But this is just I'm giving you the introduction. Okay. So this is about a binary search tree. Now in this one, so if you in linked list, what is happening? Each node, like you are storing a data. So one node is a link to another node, correct?
Yes.
In order to do this, what is the internal data structure you are using?
Node.
Okay. Can I here what should I be using? Can I use the same thing?
Yeah.
And what else? What extra I need to do? Can I say node is a class? I'll have to have one variable called data, which can be an object. It can be an integer, employee, anything. And then in the linked list, what are you doing? It is each element is pointing into the next element, correct?
Next,
Now
yes.
in a tree, a binary tree. So leave about the normal tree. We are going to implement a binary tree because that is what we are going to use in a most of the scenarios. And interview questions are also based on this. So if I have to represent a binary tree, how many children at maximum a binary tree can have at any point of time?
Two.
Two. So what is those children names?
Left
and right.
Left side.
So can I say that is also a node object only, correct?
Yes. Yes.
So that means here in the linked list, what are you doing? You are writing the class like this in the linked list: class, node, object, data, and then node next you are writing, correct? Now, if I have to convert this into a tree structure, because in the tree also, see you look at here, your root, each parent is holding the address of two nodes, correct? So that means I have to hold the address again, same thing. So what I will use? Class,
We should have
node.
left child and right child, right?
Yes, yes. Object data. And then what is the next one? Next node, left child, node, right child, correct? And I will have a constructor. By default, whenever you're creating a node, left child and right child will be null only, correct? Whenever you're adding a next time element, then only you have to form this link, correct?
Yeah.
Am I right? Yeah. Does anyone has any questions so far?
No, sir.
I hope everyone understood this. Bharati, Harish, Satish,
sir.
Yes.
Raj, Praneeth, Shiva.
Yes, sir.
Okay. Now we are see whenever I teach about this theory, it looks good. But when you implement a program, it becomes interesting. And that is how we can judge that whether you learned it or not, right? Now let us implement the tree structure. If you look at here, can I say for all this, whether it's a stack or queue, what is the underlying data structure, guys? Linked list only, correct?
Yes.
And if you are going in the form of an array, can I say custom array list and custom linked list? If you know this one very perfect, can I say learning all the data structures becomes easy?
Yeah.
Yes.
Yeah. So you yourself look at, guys. So I have taken around, in order to just to explain linked list, add, remove, I have taken around 5 days. But later, whenever we are writing the code, we are just completing within 15 to 20 minutes, right? So the learning of custom array list, custom linked list is very important. Like, why am I writing the node? Why am I making that head into a temp variable? And why am I looping it? Why I'm writing temp equal to temp.next? All those things are very important. Okay. Now we are going to create a tree implementation. That means here in the main method, I will give the data. Internally, it should show. So whenever I debug it, I should have a tree kind of a format like this. So generally, if you normal tree, if you want to implement, if it's a binary search tree, you are following something, correct? Any element lesser than the root towards left side, any element greater than the root towards right side. But if it's a normal tree, do you have any logic?
No.
I can insert wherever I want, correct? Now let's
Yeah.
implement the normal tree first. Now, what is the internal class, guys?
No.
Class node. Okay. Now, what is the object?
Object data.
Data. Node,
Left side.
left child. Or can I put it as a LC? Or let's write left child. Okay. Node, right child. Okay. Now I have to have the constructor node, object data, this dot data equal to data. Okay. Now what is the, see in the linked list, the first node is called as a head. Here the parent node is called as
Root.
root. Say that is a terminology, guys. Can I change? Can I modify this variable name?
Yes, yes.
Yes,
Yeah.
we can keep whatever we want. Okay, but generally just follow the same thing because that is industry wide that the name is used. Okay, now okay, so now first I want to call this method. Okay, I'm just creating an object. Okay, now so first can I say this is okay? What is it is showing? Okay, let's make it as a static class, then it will work. Yeah. Yeah. So here first, I just have created the root. Now, whenever I want to add a left child, right child, now I have another data called, I'm just implementing a normal tree, guys. I'm just implementing the binary tree, not the binary search tree. Okay. Binary tree, in the binary tree, in order to store the data, do I have any logic?
No.
No, correct. Now, for example, this is a representation I want to do as a normal binary tree. Now, what is my root? A, correct? Now, can I pass here A? Done. So now I have to go to what is the A left side of A?
B.
Right side of B? Sorry, A. Right side of
C.
A? C.
C.
Correct. Now, can I say T dot root? See, this root is your node. Internally, the root will have, see, node is a class. Can I say it will have dot left child equal to again new node, correct? You are inserting every element is a node, correct? So I have a new node of B. Agree?
Yes.
Now similarly, root dot right child, correct? So that means you are always starting with a root, and from that root you are creating a relationship, right? Done. Now how can I represent this? Can I say I'll start with here root dot left, correct?
Yes.
Root dot left child, correct? Equal to what is that variable? D. Now what this will become?
Child
Right.
right child.
Root
Root dot left dot right.
dot right, correct?
Yes.
Okay. Now again, let's come back to this file. A dot right I have done already. Look at here. T dot root dot right. Now how this will become G?
Right
Dot right child dot right child.
Root dot right child dot right. So later we will modify this right child to right, left child to left. Okay. The variable name. Okay. Right child dot right child. This will become G. Okay. Now here I can write anyways, whatever may be the order, it doesn't matter. Okay. Now, so this f becomes root dot right dot left, correct?
Yeah.
Okay. Now let's debug sys out root. It will print the data, but what I will do is I will put a breakpoint and I will debug the code. Okay. Debug as Java application. Now, if you look at, let's go here. Now, if you look at the root, can I say A is my root? Correct?
Yes.
What is the, from the diagram, what is the left child for A? A should have B comma C, correct?
Yes.
Yeah. So let's look at here. See, what is the left child of A? Can you say B?
Yeah.
What is the left child of B? D, and right child is E, correct? Right child is
Yes.
B, D comma E. Now let's look at here again. Now let's go to the A. What is the right side of A? See, C. And what is the left of C? F. What is the right of C? G. And does the F and G has anything left and right? No, these are null. So can I say it is similar to the diagram now?
Yes.
So that means this is general implementation. But see, if, for example, now if you want to represent say a tree, based on the tree, you will add it. But if I given, they are giving you some 10 elements in the form of array, and they're asking you to construct a tree, you can go towards left side, right side, whatever you want, correct? Because they are asking just to implement a tree structure or binary tree structure. What you have to make sure, maximum binary tree will have 2 childs only, right? But the question comes, if I am asking you to write a program to implement the binary tree, or binary search tree, then only the answer becomes difficult, correct? Yes or no?
Yes. Yes.
So now let us see, if you want to do the normal tree implementation, you can do like this. Okay, but the problem, if you are doing like this, if your number of childs are becoming more, can I say this combination, you might do some mistake anywhere?
Yes.
So
Yes.
at some point of time, I have 10th level. At 10th level, I want to construct a tree. I might mess up with the left child, right child, left child, something, correct?
Correct.
Yeah. So in order to overcome that, generally, the binary search tree is the one which can be used. Okay. Now, this is normal tree implementation. Now, let us see the binary search tree. Any questions, anyone?
So in real time, we will always go to use binary tree only, or
Yeah, generally you will use a binary tree, and most frequently you will use a binary search tree only. Because if say,
okay, because to avoid the confusion, or
not avoid the confusion. See, if you are using means you need something, correct? If you are using a binary search tree, your retrieval will be fast, correct?
yeah.
So see, mainly you will see whenever you are retrieving or whenever you are processing the data, it might take time, correct? If you are using a linked list or any other data structure. So you have the data stored in the data structure, but you want to perform the operation on it. If it is taking time, how can you reduce it? If you are storing in a form of a tree, and that too specifically binary search tree, the retrieval will be very fast, correct?
Yeah, but so if you want to use the tree, means we should only use the binary search tree.
You can use the other one also, but so generally we don't use it. That is what I'm trying to say.
Okay.
You can write the program, whatever I am writing. See, whenever you are using a normal binary tree, then do you have any sequence, whether it should go to the left side or whether it should go to the right side? See, I have shown you the diagram. Here I have drawn the diagram and I'm representing. For example, instead of diagram, I'll give you the array of numbers, 10 numbers in the form of array. And I'll ask you to represent in the form of a tree. You will just write root dot left, root dot right, something. Or you will write a program in such a way that a recursive program you will write and you will add all the nodes towards left side only. Will it become a tree? Yes, it will become. But what is the use of that, correct?
Yes.
Hope you understand, right?
Yeah, got it.
Yeah. So,
I have one question. I mean, in the real time, actually, most of the time we are dealing with the database, right? I mean, so I mean, insert search, actually, we are retrieving from the database, right? In that case, so where it will be applicable, this binary search and all.
So, so generally, if you know the binary search tree, there are two searching topics: linear search and binary search. If I do the linear search, in the binary search, what will happen is at any point of time, you are making the searches to half of the search, right? So you will understand. Okay, let me do this, and then whenever you go for the data structure topics, there is one topic called as a binary search. In the binary search, this will be used.
Okay.
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 So now we know that inner class as whether it's a tree or binary tree, whatever it is, the inner data structure is node. Let me copy this and put it here. Okay. Now here, in order to add the data, I will create one add element. See, public void add, and it will take an object obj. Now, whenever I'm adding a node in a linked list, what is the first statement I need to do?
Declare the head.
Okay, any other answers? First statement inside a add method or push method. In a linked list, we have an add method, right? We have implemented custom linked list. What is the first line I have added in the linked list?
You have to create a node.
Create a node
null.
object. Create a node object first, correct? Node n equal to new node, done, with a object that they have given, done. Now here, for example, I am calling this method like binary search impl b equal to new binary search impl. So now what I am implementing, binary search tree, correct? Now b dot add, first I will give 100 as a node, or can someone tell me any number? Any number?
50.
50. Okay. Now, so here, next time I will say b dot add. Tell me some number next.
20.
20. Okay, next. Quickly tell me the numbers.
70.
70. Next. Random number. 101. Okay. And 80, correct? Okay.
Can we have the duplicate numbers here?
It's up to you. First give the unique numbers, then we'll go into the duplicate.
Okay.
Yeah. Any number?
60.
60. Okay. Now, if I'm asking you, right, this one is right, these are the nodes or these are the numbers, write a program to implement the binary search tree. How do you draw the diagram? First, you will take what is the first element will be taken as a root node, correct? That is 50, correct? Now, next time, whenever you are inserting 20, what do you check?
Higher than or greater than?
So
Less-
you have to
less
check
than or-
whichever element you are trying to insert, 20. So that means, can I say first, whenever you are creating whenever you are adding b dot add 50, what is the first statement you need to create? You need to create a node object, correct? This is a node object which will contain 50. Now, how do I know it's a first node? How do I see in the array list, first element is a head element. In the similarly, whenever I'm representing this tree, what is the first element? Root. Can I say if the root is, so after creating a node object, if the root is null, correct? Root equal to null. Can I make the first element as a root object?
Yeah.
Root
Yes.
equal to n, done. Now you are pointing it as a root, done. Okay. Now let's instead of writing here, let's write it down. Now, can I say you have created 50 and you made it as a root? Okay, done. Any questions till now? Now, next,
No.
what are you doing? You are doing b dot add 20. So first, what do? First, you will create one object called node object. First, you will create 20. So you will create 20 somewhere. Okay. Okay, 20 I created. So, so is the root null second time?
No.
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 Then I will say I have to go to else part, correct? Now, then where should I start my logic? If there is a binary search tree implementation, can I say I have to take the root value and then compare this element with the root element? If it is less, then can I say root dot left 50 dot left equal to 20, correct?
Yes.
Now, if it is a greater, then 50 dot right equal to 20, some 60 or something like that, correct? Now let us do that. Now here, instead of left child, right child, is it fine if I keep left and right?
Okay.
Because like it is this is a general terminology. Even if you go to the tree map and all, it will have a left, right, something, etc. Okay. Now here, can I directly go to the root, or should I take the root into a temp variable?
Into temp variable.
A root dot.
So
Root dot only.
node temp equal to root. Done. After that, what should I do?
Yeah, less than 10.
I have to take the root. See, root is internal. Yeah. So first of all, so I have to compare the value, correct? From the root, I have to get the object, correct? So I will take object data equal to root dot, or else I will take temp dot root. Okay, temp dot data. Done. Now what it will give me? 50. In this example, it will give me 50, correct? Yes or no?
Yes.
Yes.
Okay. Now what I will write? If I have to compare, correct? Yeah. Data dot int value, or else let me compare this into an integer. Okay. I'm converting, guys, in order to do the integer. Data dot int value is lesser than, so it, okay. This object also let me convert into a integer, correct? Integer given node value equal to integer obj. Okay. Now, given node value dot int value is less than data dot int value, or else let me take it as a root value. Root value. Okay. Now, if it is true, what should I do?
Left. Dot left.
Root dot left.
Okay. I have to do root dot left, correct? So, but should I do root dot left or temp dot left?
Temp dot left. Yes.
Yeah. Temp dot left equal to, so basically I will write 50 dot left first, correct? 50 dot left equal to 20, correct? See, if it is true, now you will see what are you doing the logic here? 20 is less than 50. Is it true? Yes. Then you have to put 20 towards left side. That means 50 dot left equal to 20. Agree? Does everyone agree with me?
Yes.
Yeah. Now, so what is the value, which variable which is containing 50 in this example? Can I say temp? Replace 50 with a temp. Temp dot left equal to, what is it variable that is containing 20?
Yeah.
N.
Temp,
N,
temp,
correct? N. So let's do that. So can I say temp dot left equal to N?
Yes.
Done. Now, for example, immediately, so what is the third value you are adding? 70, correct? So after this, can I say I have to return? Yes or no? If I don't return,
Yes.
it will execute continuously, right? I mean, it, okay, I'll come to that. So don't write a return statement. No worries. Okay, we'll come to that. Now, next element is add 70. Now with 70, can I say first I need to create a node object? Yes. Then again, I have to compare. What is the root value? 50.
50.
And 70 is less than 50. Is it true?
False.
False.
False. That means, can I say this will go into the else block?
Yes. Yes.
In the else block, what I will do? 50 dot right equal to 70, right? Now in this
Yeah.
50 dot right is nothing but temp. 50 is nothing but a temp. Temp dot right equal to 70 is nothing but n, correct? Done.
Yes.
Does anyone has any questions so far?
No.
Everyone?
No, sir.
Okay, fine. Okay. Now let's continue. Let's take now the interesting thing will come. Now let us add one more element called 101, correct? Okay. Now if I am adding 101, so first what I will do, I will create a root element, correct? See, let us take, I will create 101 something. Okay. Now I will compare with 101 less than 50. Is it true?
Yes.
Is it true?
False.
No,
False.
false.
Can I say it will go into the else part?
Yes.
Now in the else
Yes.
part, what are you doing? Temp dot right equal to n. But currently temp dot right is holding. Temp is your root. Temp dot right equal to n means, can I say you are overriding 70 with 101?
Yes.
Yes.
That means this is not correct, right? So that means before adding, you have to check whether this temp dot right is null or not. If it is null, then only you add it. If it is not null, you need to go to that address, correct?
Correct.
Yeah. Now can I say I have to loop it, correct? So this is the if else block. Will it work?
No.
No. So that means I have to loop it. Now here, can I say here, first I've checked if temp dot left, sorry, temp dot right is not equal to null. Else, if it is null, then I should do this one, correct? Agree with me, everyone?
Yes. Yes.
Yes.
If it is not temp dot right not equal to null in this scenario, what do? Already temp dot 50 dot right 70 is there. Now can I say you have to take this value and then compare again, correct? 101
Yes.
less than 70, correct? That means, can I
Yes.
say you have to repeat this logic again?
Yes.
Now can I say I have to, instead of if block, can I say before this I have to write a while block?
Yes.
Yeah. So let's do while temp
Root.
lets me do while true. Because see, if it is a normal scenario, you will have a left and right, but let's do what I'm doing is I'm doing true while true. That means it will be true for always. Okay. Now let us run the code. Now here while true, correct. Every time it will be true, correct. Done. Now what I'm doing, guys, first time, what is my temp?
50.
50. Now here temp dot data, what I will get? So let us debug. We are adding this node, guys. We are adding 101. Can I say my node given node value is nothing but 101? Okay. Till now, everyone is with me.
Yes.
Yes.
Okay. Now, what is your root node? 50. Now, so temp dot data will give you 50. You are converting it to an integer. Done. Now, given node value here, what is the logic? 101 is less than 50. Is it true?
False.
Now, can I say it will go to the else part?
Yes.
Now, in the else part, already, so 50 dot right, what is there?
Already have 70.
70, correct? See, temp dot right, is it null? No.
No.
Then can I say I have to repeat the same logic? That means now 101 less than 50 I have done earlier. Now can I say I have to do 101 less than 70, correct?
Yes.
Yeah. So in order to do that, I have to go see how do I currently I'm at temp. How do I get the 70 value?
Assign to the temp.
Temp equal to temp dot right, correct?
Yes.
Now if I assign, again my temp will become 70, correct?
Yes.
Now again it is inside the while loop. Is it true? While true, that means it is always true. What is your temp value? 70, correct?
70.
Because you have reassigned it here. Now 70. Now here given node value is 101 and your root value is nothing but this one, 70, right? 70. Now, is it true? False. Again, it will go here. Now here, what is your temp? 70. 70 dot right. Do you have any element?
Yes.
Yes.
70 dot right. Do you have anything?
No, no, no.
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 It's null. So can I say it will go to the else part?
Yes.
Yes.
Now then here you can I say 70 dot right equal to, should I keep 70 dot left or right? Right side only, correct? Because greater than 70 dot right equal to 101. 70 is the variable which is holding temp dot right equal to n, correct? See,
Yes.
temp dot right equal to n. After that, can I say again the loop will repeat only because I have written while true. How can I break? I can call the return statement or I can call break statement, correct?
Yeah.
Now, any questions so far? Okay,
No.
now let's do this value. Let's instead of this 80, let me put it as 45, guys, because I want to go towards left side now. Here, now I'm adding this one. Now, what is my given node value? 45. Okay. Now, what is my root? 50.
50.
Here also, this is also 50. Now, 45 less than 50. Is it true?
Yes.
Oh, yes. Yes. True.
Okay, so let us take 10, not 45. Let us take 10. I'll come to the 45 later. Let us take here 45. Let's keep. Now let's keep 10. Sorry, I'll repeat again. See, given node value is 10, root is 50. 10 less than 50. Is it true?
Yes. Yes.
Now, so can I say temp dot left? Is it the right code?
Yes.
Because already 50 dot left, you have 20. You have to check temp
No.
dot left. If temp dot left not equal to null, then only if it is equal to null, then you have seen it, correct?
Yeah.
Okay. If it is not in this scenario, temp dot left not equal to null, then you have to go to from 50, you have to go to 20. How do you go?
Temp equal temp dot left.
Temp equal to temp dot left. Why are you assigning it to the same temp variable? Why not some other variable?
Because while again we have to go to while. No?
Yeah. So here in this scenario, while true I have written, you can assign, see whatever the variable you are using here, the same variable throughout the loop you have to use. Okay. Now temp equal to temp dot left. My temp value became 20, correct? Temp is now 20. Now here my temp dot data will become 20. Now 10 less than 20. Is it true? Yes. Now temp dot left, 20 dot left. Do you have any element? No. No, since it is null, temp dot left equal to n. That means 20 dot left equal to 10. 20 is nothing but temp dot left equal to n. Temp dot left equal to n. Done. After that, can I say it will loop again? Because I have written while true, correct? So in order to break it, what you have to do? You have to write a break statement or return statement, correct? Now, can I say whatever I write, can I say it will work now? Now let us take 45. Now given node is 45. You guys tell me quickly. Now can I say for temp dot data is nothing but 50. 45 less than 50. Is it true?
True.
Okay.
Also,
But 50 towards left side. Do you have a node?
Yes.
Yes.
So can I say what is the temp? Temp equal to temp dot left. Temp will become 20 again. So this 20, correct? Now 45 less than 20. Is it true?
False.
False. That means can I say where are you going? See here. Can I say you are going towards right side of 20? Correct. Now whenever it is going, again you are checking here. Temp dot temp is nothing but 20. Do you have any right side element to the 20?
No element.
No.
No. Can I say temp dot right equal to n? That means you are putting 45 here, correct?
Yeah.
Yes or no? And then you are returning. Now if I put 49, let us do 49. If I do 49, now again my given node value is 49. 49 less than my root node is 50. 49 less than 50. Is it true?
Yes.
Now it will go. Is the 50 dot left is null or not?
Not null.
Not null, correct? Yeah,
Yeah.
it is. So what is the value? 20, correct? Now again my data will become 20. Now 49 less than 20. Is it true?
False.
No, that means I'm going towards right side of 20 because I'm entering the bigger value. Now, right side of 20, what is the value? 20 dot right,
Not null.
45, not
Not
null.
null.
So you're taking temp equal to temp dot right. That means you will get 45. Now my temp value will become 45. 49 less than 45. Is it true? Again, it will go to the right
False.
side, correct? And 45 dot left, 45 dot right. Is it null?
Yeah.
Yes, then I will assign 49 here, correct? So that means whatever may be the number you are giving, can I say it will insert properly?
Yes.
Yeah. So this is a code for binary search tree adding. Hope you understand, guys.
Okay.
Yes.
Yes.
Yes, sir.
So I mean, like if I have shown already the program with you, it would have been little difficult. But can I say line by line we have written, correct? Why am I writing a while loop? Because I have to iterate every time. Why am I writing a return statement? If I do not write a return statement, it will go into an infinite loop, correct?
Correct.
Yeah. So this is how when you write the logic, even in the project, not only this one, you see, whenever you are implementing something, first you want to do some validation. So you need to identify the steps first. Generally, what the steps are nothing but you get the data from the database, correct? You write that step first. Create a method, execute a query, and get the data. On top of the data, you want to do some validation, do that. And then only you take it to the controller. How the people will do generally is, they will start with the controller and they'll write the controller logic and then they'll go to the backend. No, that is not the right way. First, your request will come to the controller, done. So you take the request, create a method in the controller. And from the controller, you have to go to the business logic. You create a method in the business logic and take there. And from there business logic, you have to go to the DAO. In the DAO, execute a query and then write the return statements. If you do that, then that makes sense, guys. So any questions on this?
Okay.
Yes, go ahead.
Is return statement required in line number 40 and 47?
49?
No, line number 40 and line number 47.
So 40 is not required. The reason, if you are returning, can I say it will execute again? See here, why are you doing this one? Temp dot left not equal to null. You wanted to see here. If after dot, there is a node. If you are returning after that statement, if you are returning, this while statement will not execute, correct?
Yes.
Yeah. See, if I do not write a return statement, it will throw unreachable code, something, the compiler itself. Earlier you have seen this blue lines of code, correct? What does it mean? Add a condition to add an end condition to this loop. That means what the Eclipse is telling, you have written a code which will never end, correct? You have to write a break statement or return statement. Okay. Yeah. So now we know how to do the tree, how to add the data. Now there are some tree traversal techniques, correct? See, if I want to traverse over array, I will just write simply for loop. But here writing a for loop will work?
No.
So the tree traversal techniques are called in order, pre-order, post-order. Okay. So in the data structures, we are going to see so many things like mirror image of a tree, like count the nodes of a tree, and where is the minimum value, maximum value of a tree. There are so many questions which we are going to cover in the data structure topic. But for collections is concerned, this is enough. Okay. So next, in the next class, we are going to see what is a in order, what is a pre-order, what is a post-order. Then we are going to look at tree map and tree set. And when it comes to the data structures, on these three topics, we have n number of questions. Let me show you that questions too.
Karthik, one last question.
Yeah.
Yeah, what if we try to insert the duplicate value?
Yeah,
Like where
even
it
if
is
you are
shown?
trying to insert a duplicate value, see here, what did I mention? See, even if you are putting 49, can I say your code will take, see 49 less than 49, is it true? No, it will insert towards right side, correct?
Okay.
Yes or no? If you are writing equals, then it will go towards left side. If you are writing less than, it will go towards right side only. Hope you get it.
Okay.
Yeah.
Like, is there any standard format we need to maintain, like left side or right side? For
No,
duplicates?
it's depends on your requirement. There is no standard because tree can allow duplicates also. Like, see, we do not have a tree data structure in real, right?
Yes.
So we have a tree map and tree, that one. In the tree map also, like duplicate keys, it will not allow because internally it will have the equals and hash code method overridden, correct? Similar to the hash map. We'll come to the tree map later, but I'm just talking about a tree. In a tree, you can have a duplicates also, not a problem. It will depend on your logic. Here, if you keep less than symbol, it will go towards right side. If you are keeping equal symbol, it will go towards left side.
Okay.
Okay. Yeah. Now, so in the next topics that are going to will be in order, pre-order, post-order. That is very, very important, guys. I'm not talking about in order. In order, if I have to look at the in order, how the in order traversal will happen. So under this, we are going to look at the recursive programming. See, everyone know that recursive programming is nothing but calling the same method again and again. But whenever you're calling, how do you come out? How the Eclipse will, see, whenever you're debugging in Eclipse, it will follow something. Tomorrow, I'm going to show first Eclipse debugging and you will not understand. Later, I will write a program. We are going to write an algorithm, how the recursion program is going to execute. And then we are going to see like in future, whenever the recursion comes, how do you follow? How do you write an algorithm? I'm going to teach that. And after that, I'm going to teach pre-order, in order, pre-order, post-order. Okay. Now, if you look at when it comes to the data structures, see here, we are going to see min and max elements present in a binary search tree. Print all the leaves of a binary search tree, height of a tree, fill depth of a tree, sum of all elements present in a tree, level order traversal, vertical order traversal, distance between two nodes in binary search tree, binary tree paths, left view of a tree, check whether the given tree is a binary tree or not, write a program to print mirror image of a tree. See, all these questions are important. These we are going to look at in the data structures. For collections, I mean, like, see, I'm not teaching all of this because collections learning the people who do not know at a tree itself. So this would be like to know the concept of a tree would be beneficiary for them. So that's the reason I kept a tree topic. Okay. So tomorrow, please don't miss the class. I'm going to teach the recursion algorithm. That would be very important. And please be on time to the class. Okay. So any questions? Yeah, Pranit, go ahead. You have raised your hand.
Yeah, I already clarified that doubt, Karthik.
Okay, fine. Sorry, I have seen now. Okay, fine, no issues. So I hope you understand now, right? Today, the tree. Is it easy now?
Yes.
Yeah.
Yes.
So guys, please practice on your own. Once I complete the in order, pre-order, post-order, I will share the code. Okay. And I have shared the notes till I think stack. So I'll update the queue and then trees, and I will share the complete notes maybe in 2 or 3 days. Okay. So we'll be completing this collections workshop on 26th, guys. July 26th. From 26th onwards, the advanced data structures, which is nothing but time complexity, space complexity, sorting algorithms, searching algorithms, dynamic programming, graphs, and those are the questions, pattern matching, matrix, all those will be starting from 26th. So we'll have the demo classes till 31st or 1st. So I see that some of you guys have enrolled only for collections. If you are interested, you can enroll, you can say, you can pay the remaining fee and you can enroll it. Or if you are not interested, that's also fine. Okay.
So
Anything?
26, you're going to start the demo for?
Yeah. Data
Okay.
structures. By 26, we are going to complete this collections. If anything is pending, I'll take a class over the weekend on 29th or 30th. If anything, but as per my schedule, will be done.
Okay. Okay. Fine.
So I hope you are able to follow, right? You have learned something new, guys, throughout this course.
Yeah, it's really helpful.
Yes, yes.
The way
So
of teaching, really good.
and see, whenever you go for a collections, like like when I say duplicates are not allowed, duplicates are allowed, it is sorted, it is not sorted. That is not the real collections, guys. So I felt that is that's where the complexity comes. Hence, I have divided this course into a collections also. Okay.
Because
Because
in one of the interview, I got that question. That's why.
which one?
Like sorting the array which duplicate elements.
Okay.
That-
Okay. Okay. Fine. So I hope you learned something new, guys, and it is useful for your career. Not only for the interview purpose, it might be useful for your project also. Okay. So in a week, we are going to complete. If you have anything, let me know. And you can happy to join for the demos of advanced data structure topics, and then you can take a decision to continue. So,
Sure.
yeah. So that's all for today, guys. We'll see you tomorrow. And no data, no multi-threading class for today. I have a meeting at 8:35, so I have to join for that.
Okay.
Yeah. Thank you, guys. Thanks for joining. Have a nice day.
Thank you.